Okay, so now we have Leo Teeth technology. Q is equal to the minimum value of twice L and 3K. So that gives us these L-shaped isoquants. So if we wanted to make 1, so if we want Q equal to 1, well 1 is equal to the minimum value of twice L and 3 times K. So that means that L has to be equal to a half and K is equal to a third, right? So if we want to get 1, we put in half L and a third K. So put us at a point like this with a half and a third. So the choice of inputs you're going to make is always going to be on this kink, right? Why would you put in more K than you need to? If you put in 18,000 K, you're still lying on, without putting in more L, you're still lying on the Q equals 1 isoquant. Okay. So you're always going to produce at this point here, this kink, where 2L equals 3K. Which means that the expansion path, we just write it in terms of K, K is equal to 2/3 of L. Okay, so that's your expansion path, and it's just to point through the kinks and all these things going up this way. So that's your expansion path. What about the input demand functions? Well, we've already argued that on any given isoquant, you're going to be obeying or satisfying this relationship. So, in other words, twice L is equal to 3 times K, gives you a level of production Q. So that means we can rewrite these things in terms of, we can take twice L is equal to Q, which gives us that L star is equal to Q over 2. That's your input demand for L. Likewise, we can take the K one, we can have 3K is equal to Q, which means that K star is equal to Q over 3. So there are your input demands. So you just recognize that wherever you are, whatever level of Q you have, you're going to be satisfying this relationship, that you're always going to be putting your production at the kink point. So the last thing we want is the total cost and the marginal cost. So get rid of this. What's total cost? The total cost is always just how much you're spending on labour plus how much you're spending on capital. And we know all these bits of information. Now we know that W is 7. We just worked out that L star is Q over 2. We know we're told that O is 5, and we just worked out that K star is Q over 3. So if we tidy that up, we get total cost of Q, so let's take the Q out, times 7 over 2 plus 5 over 3. So that's our total cost. What about marginal cost? Well, marginal cost is always just a derivative of total cost with respect to quantity. So we just differentiate this with respect to Q. Q goes, you get 7 over 2 plus 5 over 3.